Okay, so this is a presentation that I gave at Nebraska Code not too long ago, about a couple weeks ago, and I'm just looking for feedback from this group. I'm just trying to practice giving this presentation. So as I go through it, I'll say things that are very obvious, like what is builder trend? I know you all know it, but just know that I'm practicing this for future presentations. I'll ask anyone who has questions to hold them until the end, please, but feel free to add them in the chat or just remember them. And we'll have time for Q&A right at the end here. So let's get into it. This is a talk called Architect for Change, Decomposing Systems by Volatility. I'm Charlie. I don't know if all you know me. I think maybe many of you don't. I'm our lead architect within our financial services biz unit, obviously here at Builder Trend. And yes, this works. This talk is about decomposing systems by volatility. So you may wonder, why would we want to decompose a system or systems by volatility? Why not something else? Why not something that's more like domain-driven design that's more functional in nature? Why not just microservices? Surely there's a benefit to just partitioning out a monolith itself and just having microservices itself. Here's an interesting question, like why have an architecture at all? That's sort of an interesting thought here. Let's start with that. Why should we have an architecture at all? Well, it may seem like a good question, but actually if you think about this, what is architecture? What does it mean? Architecture refers to the high-level structure of a software system, defining how software components and systems are organized and interact with each other. So a very long definition, but that is to say that every software system has an architecture, from a prototype to the monolith to the fully distributed system, microservice ecosystem. So the question isn't whether we should have an architecture at all. There will be an architecture. It's whether that architecture will have deliberate thought put into it, which is why we're talking about one approach, volatility-based decomposition. So this approach that we use at Builder Trend, we've been using this actually for quite a long time, but in a distributed system context, we've been using it for about 2.5 years. Our methodology is derived from this book. It's called Writing Software from Yuval Lowy. This book is broken out into two halves, more or less. The first half is about system design itself, and the second half is about project design. Once the system has been designed, how do you make that system real? And while the system design part is really good, and our process for designing systems is very heavily inspired by it, I think the second half of the book around project design is somewhat disagreeable. So what I would say is I would encourage you all to read the first half of that book about system design, and that is what I'll explain in this talk. But I'm also going to completely ignore the second half, because when it comes to delivering value and actually building out the system, we more lean on advice that's similar to these two books. So if you haven't really heard of these two books, I strongly encourage you to pick them up and read them. They're very easy reads. The Lean Startup by Eric Ries, and Lean Software Systems Engineering for Developers by a couple guys who actually work in Lincoln down the street at Don't Panic Labs. Their build, measure, learn, and focus on outcomes, not outputs. Like that is a sentiment and a mentality that we try and strive for here at Builder Trend, and I'll get into more details later on. So let's get into the details here. Let's talk about the methodology for decomposing systems by volatility. I promise you this is the most over-the-top AI-generated image I have in here. So what I wanted to do is just give it like a general sense. Is like we, as software professionals, interact with a larger ecosystem of smaller systems. And those smaller systems are unique in their own way. And they may want to impose change on neighboring systems in their own way. The idea of decomposing systems by volatility is about being deliberate about how we contain that change so that it doesn't ripple out to neighboring systems. So again, it's completely ridiculous. And I'm sure everyone by this point in 2024 is tired of ridiculous AI-generated images, but I'm jumping on this bandwagon for now. So together, we're going to go through an example of a system that we built and designed at Builder Trend called our payment processing system. So I know a lot of you already know this, but just for the sake of practicing this, Builder Trend is a residential construction project management company. We all work here, obviously. It includes project management aspects like schedule, data logs, to-dos, etc. You can upload files. You can message your homeowners, your subs. There's the financial piece, which is what I'm more heavily involved with for paying invoices, bills, lending, insurance. So it's a very full-featured product in and of itself. On the payments front in particular, this is obviously like a huge opportunity because, as we're all aware, homes are expensive. And within the last like 6 years, maybe 4 years, they got really, really expensive. And expensive homes have expensive invoices and expensive bills. And there's a lot of money movement that goes on there. So it's a huge opportunity, not only because there's a lot of money volume, but the current adoption of technology within the ecosystem of our builders is low relative to other systems, to other industries. If we can get more builders to adopt online payments systems, then it's just a good opportunity for everyone. With large payments comes with a high risk of fraud. So we can't lose sight of hedging our opportunities and just making sure we're not being irresponsible. So that goes into context or goes into consideration for designing our systems. And then just to further set the stage here, if we go back in time to before 2022, we had at Buildertrend a monolith. It was 1 million plus lines of code. We didn't have a bunch of small systems, to be honest. Whereas if we fast forward to today, we now have about 9 systems in production, maybe a couple more coming up here by the end of 2024. Really happy about this number. Like within 2 years, we were able to go from 0 to a few systems, and one of them is just processing an immense amount of money in transactions. So let's go through just at a high level how we interpreted the book writing software and just adopt the system design process here at Buildertrend. It starts with this. We first start with identifying core use cases and volatilities. The core use cases of a system kind of identify or express the essence of that system and what the system will really do, whereas volatilities kind of encapsulate what are the areas of change that we want to be deliberate about. That's an iterative process that we'll go through back and forth together with each other. Then there's a question of like, how do you know when you're done? How do you know when the system is sufficiently scoped well enough and you shouldn't add more scope to it? And this is where call chains come in, where we start identifying what components are involved, how they talk to each other, and have we covered all of our potential use cases. Lastly, this is a little something extra that we added at Buildertrend, which is like special considerations. We'll go into some details here, but in short, this is about what is special or unique about the system that wouldn't be obvious to people who weren't familiar with the system already. So these 4 boxes roughly constitute our system design process, but that's not the entirety, because once the system has been designed, there's other ideas that we apply to this. So there are additional principles like eventing, like multi-tenancy. There are different types of systems that we'll get into, and we'll talk about why that's important. Lastly, there's an aspect of making it real, and this is where I cited those other 2 books. What steps can we take as architects, as developers, as product engineers in general? What steps can we take to start making these systems that we're designing real? All right, so let's get into this example together and start off by identifying some core and supporting use cases. A core use case is essentially something that describes the essence of the system, and a system will typically have between 3 to 6 core use cases. So a core use case describes the essence of the system, and it is composed of multiple supporting use cases. Typically, the way we annotate this or describe this is like it's a manage plus some noun. So we'll go through a couple examples here. Whereas a core use case is composed of multiple supporting use cases, and these are typically more granular in nature, and typically some other small verb and noun. So that feels like very abstract advice, but let's just get into it and just brainstorm together. So let's pick on some interns. Who are the interns in the room here? Okay, and keep your hand up if you have not seen the payment processing system design doc. Okay, so I'm looking for just spit out some use cases. What do you think a payment processing system should do? I'm just looking for like 2 or 3 examples here. And there's no wrong answers, no right answer. So yeah, you want to say something?
Pay people.
All right, so pay people. What else? Just a couple more examples.
Make rebates.
Make rebates. One more. I know you want to say something.
Yeah.
Accept payments from, I don't know, make payments, same thing, I guess.
Sure. Yeah. So we're looking for like verb and nouns. So here's some examples of just like verb noun pairs. Like, so you could pay invoice. So it's pay people, but what are we paying? We're paying an invoice. We're paying a bill. You can delete a payment. That's the more restful aspect of this. Setting up a bank account. So we know like how do you pay people? You need to set up a bank account, changing the bank account. The whole idea here is there's no right or wrong on this first pass. Just get ideas out there just to initiate the conversation about what the scope of the system should really be. And we'll note here, like there's actually going to be a lot more, but for the purposes of this talk, we're going to keep it sort of contained here so we can get through all this in less than an hour. So we just made an attempt at identifying some core use cases. Now let's move on to volatilities and maybe do a little bit of iteration here. So first, let's identify what a volatility is. Pretty simple. Volatility is something that, if changed, you wouldn't want to propagate to other systems. I juxtapose that next to a definition of variability, which is something that, if changed, could easily be handled with code if it propagated to other systems. So, example of a volatility is if you're integrating with some third party, typically you don't want those third party details to leak to other systems so that that third party can change all you want and other systems are protected. Whereas a good example of variability is something like a payment status. Payment statuses include like processing, paid, voided, rejected, like those are payment statuses. I mean, we actually had this maybe a couple of months ago where we had to add a new payment status, which is like rejected by risk ops or something of that nature. To add that payment status and then to handle that in a switch statement in some other system is fairly straightforward. And so we didn't have to put a lot of thought around thinking about that as a volatility. Something that's variable and very easy to handle with code if it changed. Just to really drive the point home here, let's say we've got 4 systems. Systems A and B both invoke System C, so programmatically via an API. System C itself, behind the scenes, using System D. So let's say in System D, there is some volatility. Something changes, and we just need to handle that. If System D is sort of out of our reach, let's say it's a third party, it may be the case that that change propagates to us, and that'd be unfortunate, but you know what, we may not have control of System D, and that can happen. However, if we've built out System C, and if we've done this in a way where we have decomposed it by volatility, then this won't happen. We will not propagate that change over to System A and System B. So it's very abstract, but this is the point here is like, there are certain things that we don't want to spread throughout the ecosystem so that we don't have to coordinate changes between teams, coordinate deploys, and just do other things that are just really complicated or really complex with coordinating changes. All right, so let's go over several examples of volatility encapsulation within a payment processing system. I already spoke to the first one a little bit, like third-party integrations. This is a very common one. So let's imagine we have 2 systems, which we do today. We have buildertrend.net, our monolith, and the payment processing system. The payment processing system will integrate with a whole bunch of different third parties. Adyen is what we integrate with today. Maybe one day PayPal, Stripe, who knows? Regardless of what other third-party payment processing system integrates with, those implementation details should not leak to Buildertrend. So the API that PPS exposes should not have anything related to Adyen or Stripe or anything like that. If we upgrade from Adyen version 1 to Adyen version 2, that is a volatility. We don't want that to propagate. So again, we should make an API that is agnostic here. Excuse me. Or if we're orchestrating between different payment processors, that's also a detail that Buildertrend should not know about. So again, this is a common example of a volatility is integrating with third parties. Payment validation logic. So let's say we've got our payment processing system and there are 2 other systems that integrate and use it, Buildertrend.net and rebates. What if we wanted to impose transaction limits, or we wanted to have some rules around chargeback exposure, validations around payments? If we wanted to do balance checks to make sure that the payment can't be made in the first place. These are volatilities in the sense that we wouldn't want to, for example, implement and contain transaction limits within one system, and then copy and paste it into another system, and copy and paste it into any other system that integrates with payment processing. These are examples of payment considerations that are so closely tied to payments that we'd want to centralize them within the payment system itself. PCI DSS compliance is a really interesting one. So this is a level of compliance that you need whenever you have raw credit card numbers touching your system. So one way we could do this is, at the very least, have our payment system host the UI for accepting those credit card payments or the credit card numbers, and then embed that within Buildertrend. That is one way of containing that volatility. Fortunately for us, we do integrate with Adyen, and Adyen, like a few other payment processors, do have their own iframed credit card entry form, which is really great because now what we can do is have that iframe hosted by Adyen, inserted into some other UI, and it's technically not touching our system. So neither Buildertrend.net nor payment processing system are under the umbrella of PCI DSS compliance. Why that's really great is because, and why this is a volatility is because what if we now need to add, what if the compliance rules change? What if they elevate? Now we need to figure out what systems need to change based on those new rules and those new compliance rules. If we do this right, that's Adyen's problem, not our problem. However, there's a way to do this wrong, which is to embed that Adyen iframe directly within Buildertrend.net. Why this would be a bad idea, despite the PCI DSS compliance being contained, we're now violating this first bullet point because now Buildertrend knows itself that it is integrating directly with an Adyen iframe. Honestly, I should be able to search the buildertrend.net code base for the string audience and not see any appearances of it. Like, I don't want it to know that audience exists. So how do we solve this specific volatility while maintaining the first and third bullet point? What we do is within the payment system, we have an iframe wrapper. That iframe wrapper, so we have the audience UI iframe. Wrapping that is a payment system iframe, and that payment system iframe itself is embedded in buildertrend.net. So there are nested iframes here, which if you didn't know what we were doing, that might feel weird or gross, or it's like, what the hell's going on here? But because what we're doing is decomposing our systems by volatility, all buildertrend is doing is integrating with a payment system iframe, and it doesn't know what's inside that iframe. It doesn't know if it's an audience UI or a Stripe UI or some other UI. It's completely agnostic to it. And by doing it in that fashion, we have maintained encapsulation on these first and third bullet points. And then lastly, we've got risk policies, case management. So, just the kinds of rules that you would expect to see for detecting fraud. We'd want those contained within our payment system as well. Now, in addition to saying, what do we want to contain within our payment system, we at Buildertrend have found it's also helpful to say, what do we want to keep out? So what are the volatilities external to the system that we don't want leaking in? Number one is product personas and permissions. And this may seem counterintuitive, but let's talk about this. Here I'm showing two types of systems. We have a product layer, which Buildertrend.net and Rebates would be a member of this layer. And we have a supporting service layer. So the payment system, the notification system, the media service, those are supporting services. So the supporting services are invoked by multiple products. But the whole idea is because the users are directly logging into the product layer, we don't want our payment system to know what a homeowner is, what a GC is, what a sub is, what their permissions are, what the preferences are, any of those personas. All that should be contained at the product layer. Now, that may come up, you may have a question like, how do you pay a homeowner to a GC if the payment system has no idea what those personas are? And the answer to that is, well, within the payment system, you still have the concept of like an account. So some entity that could be tied to a person or a company, but it doesn't know what it's tied to. It has a concept of payment methods, like a credit card or like a bank account. Again, it doesn't know who or what it's tied to, but it knows that those entities can exist. There are IDs, identifiers that are backing those entities, and the product layer handles mapping those IDs to the personas themselves. So this payment processing account ID maps to this homeowner, or this payment method maps to this GC's bank account, as an example. Next one is invoices, bills, receipts, and deposits. None of those belong in the payment system. That one also might seem kind of interesting, but if you think about this, a lot can change in these areas, and we don't want those changes to have to ripple, because those changes for sure will happen within the payments, within Buildertrend.net. We don't want those changes to have to be coordinated and ripple across the payment system. As the architect of the system, I want the system to do one thing and one thing well, and that is move money from point A to point B. And it can do that within the context of an invoice, a bill, a rebate disbursement, but it shouldn't have to care about that additional context. Financial reporting is actually a similar argument here. I don't want to teach the payment system like what a cash flow report is or anything like that. Anything that would be specific to a persona. What it should do is make the data available, and then a product should be able to consume that data and generate context-specific reports. Metered billing. So what if we want to charge some amount of money based on how many payments are made in a month? Shouldn't the payment system have some say in that? Well, the answer is no. What the payment system should do is when payments are made, it should emit an event, and we'll get into details here later, to Buildertrend, and Buildertrend will say, I see that events are coming in, and therefore payments are being made successfully. And now it's Buildertrend who's working with its ChargeBee partner or its subscription service in order to understand how much to charge the GC. So metered billing, not part of the payment system. Similarly, like we don't want to get fancy with transaction fees. We don't want to create, for example, like a transaction fee profile. So how do we exclude this volatility or keep changes from rippling into the system? Well, in this particular example, we do it by designing the API in a certain way. And the way we design it is, in order to make a payment, tell us the currency, tell us how much, who's paying, who's getting paid, but also pass in the transaction fee. So now it's completely agnostic to the use case. And if the fee needs to change, that's great. The product that called it can change that fee, and the payment system doesn't need to know about it. That's how we prevent complicated concepts from rippling into the payment system unnecessarily. Okay, so we spent quite a bit of time here, and the whole talk won't be like this, but we spent a lot of time here because this is where we identify the full scope of the payment system, and it's really important to get this right, because getting it right means can lead to a lot of success later on. So note here, this is iterative, so let's just do one iteration and then move on. These are the use cases we showed earlier. I'm going to cross out all of them based on the volatilities we just talked about. Pay invoice, pay bill. The payment system shouldn't know about invoices and bills, so we're just going to make it agnostic. It's make payment. Delete payment, actually, that's a little bit too restful, and you can't actually delete a payment. A payment can be attempted, and then it can be voided or rejected. Like, you can't actually delete it. So we're just going to change that to void. You can set up and change a bank account, but there's a more general concept that we're going to apply here, which is payment methods. So you can add a payment method, change a payment method. And then let's not forget that there are actually different kinds of use cases to consider here. So everything I just talked about so far was a user-driven use case, which is to say that it's a use case that was the result of someone clicking a button in the UI. But some use cases are system-driven by background processing, by a webhook. So updating the payment status or a refund or chargeback is coming in. These are additional use cases that this system should be able to handle. So for the purposes of this discussion, there are two core use cases for this payment system. There is the ability to manage payments and to manage payment methods. Those two core use cases have several supporting use cases. Manage payments has make, void payment, process a refund, chargeback, and update the payment status. Notice there are both user-driven use cases and system-driven use cases. And then manage payment methods, the supporting use cases are create a payment method, change it, remove it, update it, and so on. Again, our actual payment system is much more verbose and larger than this, but for the sake of teaching the concept here, we'll stick with those two. How do we know when we're done? Well, we're going to get into some call chains. This step means like we are attempting to validate the architecture. And what does it mean to validate the architecture? To validate the architecture, you first create call chains for all use cases. I'll go into a couple examples here in a second here. And a design is validated. A design is validated that the architecture can satisfy all known and foreseeable future use cases. So just keep in mind that when we design our systems, yes, we want to design our systems for what we plan to do next or this year, but we should also keep in mind of the future roadmap and vision for what we know will be coming down the pipeline. So we know, for example, like rebates and lending and other concepts were coming down the pipeline. So we want to be able to anticipate use cases around those areas, but we don't want to get too crazy. Like crypto kind of came up as a joke, and we're like, there's no way crypto is ever going to be part of this. So we did not make any attempts to accommodate cryptocurrency because let's be honest, it's not happening anytime soon within our industry. So before getting into a specific example, just to introduce some terminology, this comes from actually the book Writing Software, where you have a layered approach to designing your specific solution. There's a client layer, a business logic layer, and a resource access layer. Each of these layers itself encapsulates some volatility. So our volatility-based decomposition actually it's almost fractal. It's like it works at the system level, but also works within the solution itself. So for example, at the business logic layer, we have managers and engines. A manager encapsulates and orchestrates a set of related use cases. So in other words, it'll be like do activity A, then activity B, then activity C. If true, then activity B. Like it's that level of orchestration, almost like human readable level of orchestration of a set of related use cases. An engine, on the other hand, is a way of taking one of the activities and saying this specific activity is volatile, which means like it can change and it will change. So we're going to break that off into a separate class and contain that change there so that the orchestration module doesn't have to care about when that specific activity changes. And then there's a resource access layer, which is, we refer to these as handlers, which just how we integrate with our database, our third-party APIs, and they encapsulate those volatilities. So going into a couple examples here, here's a make payment call chain. So this big box is our payment processing system. We do have a layered approach with client, business, and resource access. Buildertrend.net, when making a payment, will invoke a endpoint, which gets directed to a controller of the payment system. That controller then talks to a transaction manager, and there may be some simple validation, and assuming the validation passes, then it will call into Audion and update some status in a database. You notice here, it does punch over to a validation engine. And the reason for that is because what makes a payment valid is volatile between a check, a credit card payment, a bank, an ACH. There are many different kinds of payments and therefore different ways of validating whether that payment is valid. And that's why we punch over to an engine for that specific activity itself. Also note here, there is no like annotated arrows, there's no labels, there's no ordering. We're just trying to figure out what components do we need on the screen and which ones are touching other components. Going over the second example here, here's an update payment status call chain. So Onion will say, hey, this payment was completed successfully. It will via a webhook call into the controller. The controller will say, hey, that's great. I know what use case I'm going to kick off in a transaction manager. So it kicks off that manager use case. The manager will likely update some database value by going through a handler, and then it'll emit some event so that some other system can respond to that payment being successfully updated. Okay, so all components should be used in at least one call chain, and any unused components should be removed. So this is a good step to identify, have you prematurely created extra managers, extra engines unnecessarily? The way to know that is create call chains for all use cases. And if there's anything that's basically orphaned, you don't need it. Get rid of it. It really is that simple. Moving on to special considerations. So what is unique or otherwise not obvious to readers consuming this system design documentation? We just felt that this was really helpful, especially when certain weird edge cases popped up. Just more or less like, this is a way to save yourself a bunch of meetings because there are some things that are not obvious with the payment system. So here are a couple examples. Payment processing system, we talked about this, a wrapped iframe for credit cards. You basically have an iframe within an iframe that's embedded in another product. That feels weird, borderline bad, but again, when we unpack this in our system design document and explain this is why we're doing this and how we're doing it, that helps save a lot of conversations and just express why we're doing that in the first place. Chargeback exposure is kind of interesting at Buildertrend when we integrate, because we integrate with Audion as a payment processor, we are liable for chargebacks. And so we therefore have a way of calculating chargeback risk. So this is right out of our documentation. The risk of a chargeback reduces over time. And if particularly over the first 10 days, it reduces dramatically. Therefore, payments will be bucketed into time range categories. So this is part of our description here. I have 3 example payments made in January and February, amounting 10,000, 20,000, and 10,000. And it looks like I wrote this documentation at the end of February because based on when today is, those payments get bucketed into certain categories. And if it's in a category that's long enough away from today, then the amount of risk, the amount of like loss that we would expect to have is relatively small. For those first 2 payments, it's under $1. But because this third payment, even though it was $10,000, because it was made in the last 10 days, according to this documentation, the amount of loss we would expect is actually much higher than that. What's interesting about this and why we explain this is because like billers are allowed to transact until they exceed some threshold or some limit. So what could happen is like on a builder is transacting, week after week, or their homeowners are transacting, and then one day their payments get rejected. And the builder's like, what the heck's going on? And then the next day, the homeowner retries the payment and suddenly it works. This feels like a bug, but what actually could have happened was there were a whole bunch of payments and some of the payments moved into a different bucket, therefore drastically reducing the exposure amount and then getting us under that limit, allowing the GC to transact again. That's not obvious. And that is why we include this in our documentation to just explain, hey, feature not a bug, like for real this time, that's a feature. And we do that for this reason. Okay, next up, going over some additional guidance. So let's get into it. Number 1 is like multi-tenancy. We strongly encourage and strongly want to design our systems to be multi-tenant by default. What does that mean? It's basically like this data firewall concept. If there are multiple tenants within a system, it should be logically and physically impossible for tenant A to access tenant B's data. Like that's just the general concept here. One phrase I used to use back in 2022 when we were first implementing this is pretend you're implementing Stripe. So like this actually, if you take nothing else away from this talk, just take away this phrase, like pretend you're implementing whatever it is a competitor to the system you're writing. So would Stripe, should someone who has a payment ID from Buildertrend, who's not at Buildertrend, be able to retrieve the details of that payment? So should the Home Depot, if they have one of my payment IDs, be able to retrieve those details? No, because they're a different tenant. Should Stripe care about invoices, bills, et cetera? No. Should they care about homeowners? No. Should they care about GCs? No. So it's like, this is a very good like course corrective statement to use if you're trying to figure out, does this belong in the system? Well, no, because it's multi-tenant and we just want it to be agnostic to those tenants. So just a sort of like a somewhat cartoonish example, but take Microsoft Outlook. So your emails as an example. Here we've got Builder Trends email organization and the Home Depot's email organization. Even though there is an employee A, an employee B, an employee C, and even though there is like implicit access controls preventing employees from seeing each other's emails, there is a hard data firewall between these two organizations, and it is logically impossible for employee A or anyone in Builder Trends organization to see an email from someone at the Home Depot. This is an analogy of what we're talking about when we're talking about multi-tenancy and a data firewall concept. So here's how we think about tenancy in the different environments. So we have our Builder Trend ecosystem, and then perhaps in the future, there may be multiple tenants. So in production, we just have one tenant today. In the future, if there's more tenants, they will just have a different unique identifier. But despite that, production and sandbox and all the other environments have unique tenants from each other. And that actually is really great because in particular with the sandbox environment, all other environments that aren't production integrate with sandbox. So if you have a payment system that is a sandbox environment and you've got a local dev BT.net or an ephemeral rebates or some other system, they all have different tenants and they're able to have a hard separation within the payment system sandbox. So multi-tenancy is valuable even if we don't have multiple tenants in production today. So a couple examples of how we implement multi-tenancy or could implement them. One is database partitioning. So what we could do is have distinct databases by tenant itself. We don't do this today, but it is an option for us. What we actually do today is forward key on a tenant ID. So it's kind of like the next best thing for like having physically separate databases. Another example is identity key segmentation. I'm just curious, who here has heard of what an identity key is? Okay, so new concept. Okay, so an identity key is the idea of attaching a unique identifier to an API request so that if two identical requests come in quick succession, you know whether they are actually duplicative or unique. So this is extremely important in the payments world because let's say someone is paying two invoices that are paying two payments on the same invoice and it's split evenly down the middle. It's like $50,000 payment and a $50,000 payment. Take that example next to someone accidentally double-clicked a submit button. In either case, there are two requests being made to the payment system. The payment system needs some way of saying, here's two $50,000 payments. Should I run both of them or was one a duplicate? The way to distinguish that is within the request header, there will be an identity key. And if they are unique requests, there will be a unique ID there and it'll not process the second request. So we have an identity key in the header when we make requests with the payment system, but we don't want this key to overlap with other tenants. The real simple way to do that is to prepend a tenant ID to that identity key. Now it's completely impossible for two tenants to provide the identical identity key because they don't have control of the true key that we actually use behind the scenes. In a similar fashion, we actually have a media service. And so we have a media service for handling files, uploading file or downloading file. And likewise, if a system wanted to upload a file and the full file path was user ID / job site ID / file name, that's probably unique, but not guaranteed to be unique. So behind the scenes, what we actually do is prepend a tenant ID and the system has no idea that that's happening behind the scenes, but that is a way to ensure that a tenant cannot stomp on or retrieve a file from another tenant. It's just a way of like having this data firewall concept. Another principle here is like eventing versus queuing. I'm going to go into eventing in particular, but first I just want to talk about how eventing is different from queuing. For reference, this is like an enormous topic. I'm not doing it justice, but I'm going to try and just give some sort of a intro here. For eventing use cases, the thing that's emitting the event, the publisher has no idea what needs to happen, what happens next, or it doesn't need to know what needs to happen next. So in other words, like something important happened within the system, I'm going to emit an event that it happened, and then something else is going to figure out what happens next. That's different than queuing where the publisher knows exactly what needs to happen. So a common use case here is like, what if we need to, I don't know, convert a document to PDF or do some like long running process that we don't want to do synchronously in the request. That's an instance where we would like enqueue a job to do a specific task. And the thing that's enqueuing the job knows exactly what needs to happen next. It just doesn't want to do it in real time synchronously. So we saw this call chain earlier. This is the update payment status call chain. And this is the eventing concept in action here. When a payment status has been updated, it goes via webhook into the payment processing system. But note the transaction manager doesn't call out to builder trend because it actually shouldn't care whether when a payment status is updated, do we need to notify the homeowner? Do we need to notify the GC? Do we need to update some other value? Again, it doesn't care what needs to happen. It just knows that perhaps something needs to happen. So it will emit an event. Here it says message bus, but really this is pub sub. It'll emit an event called payment status updated, and builder trend is subscribed to that, and it'll figure out what to do next. And any other systems that subscribe to that could handle that and handle it in their own unique way. So that is why we use eventing, and it's also a good way to decouple systems and keep those use cases and those volatilities contained. Earlier, I showed this diagram, and this is going to be talking about, we're going to be talking about like different types of systems. So what is a system? What are the different types, and what is a subsystem? I showed this, and I said that like there were two types of systems. There's a product type and a supporting service type. But then I also didn't speak to like these subsystems in the middle here. So let me just speak to those real quick. So what is a system and what is a subsystem? A subsystem is basically embedded with the larger system, but it may not be worthwhile to deploy it separately because it's so strongly tied to its parent system, or there may just be other reasons. So let's get into like those other reasons. BuilderTrend.net, huge monolith, a lot of existing code, and we are deliberately moving forward with like having multiple systems. And within BuilderTrend.net, we have job management, estimation, and financial management. However, it's not the right time right now to make those separately deployable services, if even we want to do that. It may just be worthwhile to have sort of a logical separation within the monolith itself. And that's why we are working towards that potential or that future vision within BuilderTrend itself. Just to contrast the two concepts here between a system and a subsystem. A system typically owns its own data, is deployed separately. It speaks to other systems via an API, so using machine-to-machine authentication and communication. And it's multi-tenant by default, unless it happens to be a monolith that was built 16 years ago, and we did have a chance to retroactively include that concept. But new systems going forward are multi-tenant by default. Whereas a subsystem typically shares the database resource. Important caveat here is like it may actually use the same database, but it should have its own tables for the most part. And the caveat here is like for the most part, there may be a subsystem within BuilderTrend that shares the builders table or shares the job sites table, but not more granular concepts that only that subsystem owns. It talks to other systems via machine to machine, but maybe it talks to other subsystems that are neighboring within its own parent system with direct calls. And the tenancy strategy is whatever its parent is. So if it's in the monolith, there's still multiple tenants, but if it was a subsystem, one of the newer ones we built, then it will be multi-tenant by default. And then the last piece of guidance here is have a reference architecture. So like, in other words, we should and we do have a reference architecture to reinforce the ideas that we want to have repeated going forward. And not only do we want to like reinforce that, we want to make it as easy as possible to repeat the patterns that we want to have repeated. So I showed this diagram earlier, and we actually have two ways of doing this. One is we actually have a Git repo called reference architecture, where we show here's an example solution from an example call from the controller to a manager to an engine to a handler. How do we do our documentation? We use Swagger. How do we authenticate? We use OAuth. How do we handle configs and secrets? And those examples are in there. How do we do testing? We have example tests in there. So we have a reference architecture that give full examples of the patterns we want repeated, so that again, it's easier to repeat those patterns. And then we also have like a library that you can pull into your solution called framework. And this is a separate repo where we have common components like middleware, like for example, an idempotency key middleware is one of our common components, utilities and other just shared functionality. So these are, and then again, I'm at a conference talk, I usually have an audience full of architects or architects, people who wear the architecture hat. This is advice for if you were to take this back to your own company, you would want to have this in place to make the patterns that you're putting forward easier to repeat. So a couple of benefits here is like by having a reference architecture, it documents your architecture in living code. The living code here is important. So like you actually need to deploy your reference architecture and like make sure it works. It's not very helpful if it doesn't actually deploy or it doesn't work. As you update patterns, which patterns will change, it just happens. Update the reference architecture as well. Like make it the source of truth for your patterns, because we all know documentation doesn't really get read, but when you fork a repo, like the patterns are already there. And then I've said this a few times now, make it easy to repeat the patterns that you want repeated. And then on time, we're doing pretty good on time. And this is the final section here. So last section here is like how to make it real. So it's like, it's one thing to design a system, but if it never gets implemented or built, then like, what's the point? So here's some advice on how to take the initial first steps to build momentum for getting it built. Number one is database schema sketches. So there are 3 pieces of advice here, and this is the first one. As an architect, when we were designing a payment processing system, I started putting together a schema alongside with one or two dev leads. And the whole point of this was not to make a exhaustively accurate database schema. It was more to communicate the concepts. And the concepts I'm communicating here is like within the payment system, obviously there are payments. Like that is a core entity within the payment system. But there are different types of payments. There are audio payments, checkbook payments, wallet payments. There are a whole lot of different types of payments where there are additional fields we need to track. Do we want a payments table, a single one with 80 columns? No. So instead what we have are extension tables. And actually what I'm doing here is I'm making it very obvious that if we integrate with more payment processors, what the pattern to follow should be very clear from doing this. Another entity that's very obvious, we have payments, but you can't make a payment without a payment method. So we also have payment methods as a core entity. And likewise, a payment method can be a bank account, a credit card, a wallet, a whatever else in the future comes up down the line. And then lastly, these are all tied together with an account, and an account will ultimately be tied to a company, a GC, a homeowner, a sub. But it also tells you what you can and can't do with the payment system. Can you accept payments? Can you send payments? Can you do any other capability? That is a concept that we hold within here and within the account. So again, just trying to like put the core concepts out there to make it easy to repeat and extend as we go forward. API contract sketches are a technique I've employed in the past. So what you're seeing up here is an example for the media service. Within our, and sorry to switch gears, but this was actually like a really good example of this. Our media service, you want to upload or download a file. In order to upload a file, you need to generate what is called a signed URL. And so it's like, one way to approach this is like, I could just go talk to the lead developer and say, hey, you need signed URLs, and just kind of like verbally describe how this should work. Or what I could do is be like, we want signed URLs, and this is the concept that I'm thinking of. Let's get feedback from the lead dev to understand, like, is this making sense? Is there something I'm not thinking of? And just make it more conversational. So how does this work for the media service? If we wanted to upload 2 files called, I guess I call them the same thing, file name one, there's 2 files right there. We would say, hey, media service, here are 2 documents we want to upload. Here's the metadata for those documents. And I want you to generate me a signed URL that's valid for 5 minutes. So this is already like putting some topics on the board or talking with that lead developer and like, what is a signed URL? What does it mean for it to be valid? What are valid expirations for that signed URL? And kind of getting the conversation going and the momentum going. The response we get back, ignoring some of the stuff at the top here, is like there's some response we get back from the media service is a documents array. And part of that documents array contains the signed URLs that comes back from the media service. And then there's a subsequent request where we put to that signed URL the file and a few headers. So all I'm doing here is like just stubbing this out. When I say signed URLs, this is what I mean. It's a request, signed URLs come back, and then for each signed URL, you need to put to that signed URL with the document itself. Again, just trying to like further explain these concepts and again, build momentum that goes into maybe a prototype or maybe those first few user stories for building that system. All right, last point here, you can take a very brief detour because there's a third piece for making systems real. The detour here is like, yes, I'm an architect at Buildertrend, but prior to Buildertrend, I inhabited roles where I wore a lot of hats. I was a solution architect, dev lead hat, scrum master hat, DBA hat. Sometimes I was a dev manager. It's a role I inhabited where it gave me kind of a unique perspective on agility with multiple different teams in multiple different companies. And so I need to do just a brief digression on agility because, again, breaking through the fourth wall for a moment here. This talk is meant for a conference where there are a lot of people from a lot of different companies. And generally speaking, I still see throughout the industry some confusion around agility. So I want to take a moment to clarify the confusion. And maybe just giving a hot take here. Here are some things that if you're doing, it doesn't necessarily mean you're agile. So I think these first three are a little bit obvious. Upfront detailed planning and staffing and Gantt charts, like those three itself feels obvious. I'll explain why in a moment, why I call those out specifically. But if you're using burn down charts, sprints, story points, if you're iteratively building, these all sound very agile. But if the goal of what you're doing is to build a system or to build a feature, that's not agile. Just gonna put it out there just like that. It's like, that's not what agile means. Earlier in this presentation, I recommended two books, the Lean Startup and Lean Systems Programming for Developers. I think it was the name of the book. On top of that, there's an Agile Manifesto and 12 Agile Principles. I'm just going to condense all that down into just a few words. In order to be agile, you need to continuously and incrementally deliver value to users, like full stop. If you're doing that while using sprints and story points, that's great. If you're not using sprints and story points, that's also great. Like, you're still agile if you're continuously delivering value to users. I made a note around like the upfront detailed planning, staffing, and Gantt charts. The book writing software, the second half where it does the project design, explicitly calls these things out, calls it agile, and it's kind of infuriating because really what it was is like waterfall.
Any waterfall.
Yeah, well, actually, it wasn't even mini waterfall because the users, no users, actual users, use the system until the very end. It is definitionally waterfall, where you just like backload all the risk and juxtapose that next to like continuously delivering value. That doesn't come at the end, that comes incrementally all along the way. The other thing to note here is like, to deliver value to users, it may involve building a full feature or a full system. It may involve building a partial feature or a partial system. It also may involve writing no code at all. And I think that's like a concept that gets lost among people who are like just used to writing code for their day job. It's okay to, at the very beginning, obtain value by doing something manually and not writing any code, because at the end of the day, the GCs don't care what code is behind the scenes, they just care about the value. And we're here to give value to our GCs and our customers. The other nuance here is like, move on to what's next once you've hit diminishing returns. And this is to the comment of like, you may be working on a feature, but there may be an adjacent feature that is the next most valuable thing to work on within a coherent like vision that you're working towards. So let me actually move on to this next slide and give you an explanation of what I mean. Let me take us back in time to January 2022. This is when we were just leaving our one monolith phase and getting into multiple systems, and we were about to build a payment processing system. At the turn of the year, we were having conversations around, okay, here we go. We're doing our first system. It's the payment system. We went through the entire design that I just took you all through right now. Over the ensuing weeks, we worked with infrastructure, cloud engineering, the dev leads who we thought were going to be involved coming up, and getting them included and bought in on like what was about to happen, because building a multiple system ecosystem for the first time is like unique and interesting. In March, the work began for building out the payment processing system in service of a specific use case. That use case was to offer a digital check solution to our subs at GCs. By the end of that month, the teams involved had the ability to sign up and add a bank account. And a sprint later, they had the ability to pay a bill. And that was released. 2 sprints later, sync with accounting release. A sprint later, mass pay. So now not only can you just pay a bill, you can pay multiple bills. There's a release right there. Notifying GCs or homeowners or subs released. The ability to void payments. So here's something interesting. For the first 2 months, you cannot void a payment. Sort of. You couldn't void a payment in the product. In order to void a payment up to this point, a GC had to call in to support, and support had to log into checkbook.io's admin UI and manually void the payment. That is some incremental value for the GCs, and now there's even more value to do it within the application itself. Being able to verify your bank account if it's a credit union via microdeposits. that was released shortly after. What else do we have? Status updates, the ability to like cancel your membership if there's suspected fraud. Now, this is after we get to, a certain point of March, this is continuously and iteratively delivering value to our GCs. Like this is what we're looking for. And I know I put like release down here, and I'm sure like Brockman or Drews is on call right now to call BS, but would it be more accurate? It'd be more accurate for me to say that these are releasable moments, because really that is a primary goal of a software development team, is to create those incremental releasable moments. And whether we actually release is actually a business decision. We may not want to release yet, but they should have the option to release incrementally as part of that. So going back to the like focusing on diminishing returns, note here that as soon as we had the ability to pay a bill, we immediately pivoted to a concept that we haven't talked about at all, accounting. Like, this is not part of the payment system, but it was the next and most important thing that we could deliver to our GCs. And that's why that was the next focus there. So this is a value-driven roadmap, not a build out the entire payment system driven roadmap. Okay, so finishing up here, I showed this slide earlier on, why decompose systems by volatility and why not domain-driven design or just being arbitrary with microservices. I hope by going through this, it's been pretty clear. Let me just add a punctuation mark and explain why volatility-based decomposition is so important. I just showed a timeline that went from January 2022 through July 2022. In August, mid-August 2022, we have a press release, Builder Trend Payments, a new way to pay your subs and vendors. So we go GA with this ability to pay your subs via digital checks. And actually around that time, we were all at the CHI Health Center downtown getting $1 payments as sort of like a broad, like, hey, this thing works. Here's $1. So that was interesting. Meanwhile, we're working on the next most valuable thing for our GCs, which is like ACH payments, and just running like little $1 tests between myself and the dev lead. And the next headline, February 22nd, Audion and Builder Trend partnered to bring embedded finance to construction businesses. So we're already working on the next thing and then releasing that in a headline 6 or 7 months later. Meanwhile, while this is being released, being a press release, we're looking at how do we support our partners in rebates, because they need to disperse rebates, and that's moving money from point A to point B. So how do we support that alongside our wallet products? And how do we start buying down risk for chargebacks so that we can really use Audion at scale? Now we've got November 16th, again, later that year, introducing Builder Trend's construction rebates program with Ferguson. So that's another press release. Meanwhile, we're looking at how to integrate lending, which is an interesting thing that we haven't talked about, but that is a payment system use case. And 2 months ago, Builder Trend partners with Nelnet Bank to provide homeowners financing directly through their general contractor. So why volatility-based decomposition? Well, what you don't see up here is like, we had to like stop and rewrite the whole thing because we tied payments too closely to invoices and bills. That's not in here. So it's like, this is why we want to decompose systems by volatility. I also like want to make very clear, this isn't my success. This isn't product engineering success. It takes a small village to be successful here. They're like sales, risk ops, payment specialists, marketing, I'm going to miss a whole bunch of groups, but it takes a lot of people to be successful, but you can't be successful if we have to do a major rewrite 12 months into the system. I just want to make that very clear. This is why it's so important to contain change so that it doesn't just hit the brakes as you're executing your roadmap here. It looks like I'm just at my time here. So that was my presentation that I'm practicing for various conferences. I know we're past noon. Thanks for the clap emojis online. If there are any questions in here, I'll take those. Otherwise, I will also look at questions